Hello, everyone. My name is Ryan Jones, Solutions Architect for watsonx with a focus on Assistant and Code Assistant. Today, I will be providing an overview of the watsonx Code Assistant products. Here you can see our team of watsonx Solution Architects and our support functions. As a group, we all cover watsonx.ai, but we all each have our own specialties. From left to right, we have Damon, who covers .governance, Taylor covering .data and Cloud Pak for data, Sophia specializing in Orchestrate, myself focused on Assistant and Code Assistant, and David focusing on Aptio, Instana, and Thermodynamics. In the top right corner, we have our leader and supervisor, Steve, specializing in data and AI. IBM watsonx Code Assistant is the flagship offering in a suite of generative AI code assistant products, which also include offerings from Ansible Automation Platform and IBM Systems Modernization via Code Assistant for Red Hat Ansible Lightspeed and Code Assistant for Z respectively. Developers and IT operators can utilize watsonx Code Assistant to speed up application modernization efforts and generate Ansible-based automation jobs to rapidly scale out IT environments. watsonx Code Assistant offerings are powered by IBM Granite Foundation models that include state-of-the-art large language models designed for code. For offerings such as Watson Code Assistant for Ansible Lightspeed and Watson Code Assistant for Z, bespoke code models tailored to working with Ansible Automation Platform and COBOL to Z use cases are invoked. Universally true for all of watsonx Code Assistant offerings is that they are geared towards helping IT teams create high-quality code using AI-generated recommendations based on natural language requests or existing source code. These AI models and the recommendations they generate are seamlessly integrated via extensions with the world's most popular developer IDEs, including VS Code and Eclipse. IBM Granite Code, also called Granite.code, empowers developers by accelerating software development tasks with AI-powered capabilities, including context-aware code generation, explanation, documentation, translation, and unit test generation. IBM Granite Code models are a series of decoder-only models for code generative tasks trained with code written in 116 different programming languages. The Granite Code model families consist of models ranging in size from 3 to 34 billion parameters in both a base model and instruction following model variants. These models have a range of uses from complex application modernization tasks to on-device memory-constrained use cases. The larger the block size for the particular language on the chart, the larger percentage of training data of that language was used to train the Granite Code models. Languages and formats such as Java, C, JSON, JavaScript, HTML, and PHP are subjects in which the model excels. Other models such as Ruby, SQL, and Swift have less training data to base those recommendations on, but will continue to evolve as the Granite models mature. For those familiar with other IBM watsonx Code Assistant offerings, such as Watson Code Assistant for Red Hat Ansible Lightspeed and Watson Code Assistant for Z, the generalized code model approach as seen here differs from the specialized code model approach of those two offerings. The Watson Code Assistant for Red Hat Ansible Lightspeed flavor of IBM Granite Code models specializes only in Ansible playbooks and YAML. Similarly, the IBM Granite Code model used by Watson Code Assistant for Z specializes in transforming COBOL mainframe code into modernized Java code. Ansible playbooks, COBOL, and Java are all supported languages in the generalized IBM Granite code model, and therefore are supported by IBM watsonx Code Assistant. But if a client wishes to specialize in those particular languages and frameworks, they would be advised to utilize the bespoke Watson Code Assistant for Red Hat Ansible Lightspeed and Watson Code Assistant for Z offerings to do so. Since the availability of watsonx Code Assistant for Z, the workloads are falling under two themes in most clients: modernizing COBOL and transforming to Java. In the modernized COBOL theme, Watson Code Assistant can understand your application, helping it understand the relationships between the data and the programs. Code documentation with code explanation, which is the capability that generates rich explanations for the code. Code refactoring, which is breaking the application into modular business services. And Code Optimization Advisor, which recommends improvements to the code. In the Transform to Java theme, Watson Code Assistant can transform COBOL to Java, and this comes with improvements to the large language model every month, so it's constantly getting better. It can also auto-generate JUnit tests, and this is used to validate the semantic equivalence between the original COBOL code and the generated Java code. There are three main points to highlight about watsonx Code Assistant for Z. The lifecycle approach. IBM is considering all the steps that clients have to take in their application modernization journey as part of this solution. Quality of the code. IBM can generate high-quality Java code that is maintainable and it is object-oriented, which is a big differentiator for this type of solution. Interoperability and optimization, meaning clients can leverage both COBOL and Java because both languages are strategic to IBM Z. IBM wants clients to make the technology decision that makes sense for them, and no matter what the client selects, the code will interoperate in IBM Z and it will deliver all the qualities of service that they expect from running their mainframe workloads on IBM Z. IBM watsonx Code Assistant for Red Hat Ansible Lightspeed is a solution that uses generative AI to accelerate Ansible content creation. Using this solution and approach, developers and clients across the globe are creating Ansible content faster and at a lower cost. The adoption and use of this solution is helping those clients to reduce the overall Ansible learning curve and reduce the IT skills shortage. Watson Code Assistant for Ansible Lightspeed simplifies the process of generating Ansible playbooks by using natural language inputs in the Ansible task description. Through capabilities for content source matching, clients gain transparency into the potential sources used in training data for content recommendations, including the author and license. Generation of code, either for individual Ansible tasks or full playbooks, can be produced using natural English language statements. Code explanation allows AI to take the guesswork out of what a block of code performs and can rapidly improve the quality and maintenance of code by generating inline documentation. Here you can see an overview of how IBM watsonx Code Assistant for Red Hat Ansible Lightspeed works. The product meets developers where they are with a rich plugin via the Ansible Visual Studio Code extension, where developers can input their prompts directly into the code editor. Prompts are sent to the Ansible Lightspeed service, and the service sends a suggestion back that's powered by the IBM watsonx Code Assistant Granite code models. It is important to note that all data in transit is encrypted and temporary, so users can be confident and have trust in the security of the service during this exchange. In order to utilize the product, a client must have an existing license for Red Hat Ansible automation platform, as well as a license for IBM watsonx Code Assistant for Red Hat Ansible Lightspeed. Let's look at a quick example of watsonx Code Assistant for Red Hat Ansible in action. We'll first experience the Code Assistant generating code for multiple tasks from a single natural language prompt, and then have it explain that code to us in natural language. As we see here, we have a natural language prompt with parameters already set up, and let's see what happens when we hit enter at the end of this line. This will go ahead and generate our code that we're asking it for. After a couple moments, we can review the code, hit tab to accept it, and there you go. With just that small line of natural language telling it what we wanted it to do, it generated that code for us. And if we're confused on what it provided for us, we can go right here and explain the current playbook. And with another click of a button, the explanation will generate. And now that the explanation has generated, we can see that there is a summary that explains what the code is supposed to accomplish, along with a explanation of all the tasks incorporated with the code. I want to thank you for watching, and please reach out to myself or my team members referenced at the beginning of this video with any questions or opportunities. Thank you.